Hi, it's very exciting to be here and having the invitation from Mark to do this special session, research in the area of Neosentience, Biomimetics, and the Insight Engine 2.0. I'm a professor. I work with the PhD program, Computational Media Arts and Cultures. I'm the co-director of the Emergence Lab. I'm a member of the Duke Institute for Brain Sciences, also DIBS. So, in terms of what I'm going to be doing, we have a full session tomorrow, both about Neosentience and then about this Insight Engine. So the Insight Engine is basically a tool, a high-level AI system that then enables us to build a higher order AI system or even post-AI, this Neosentience. And so I'm going to be doing a definition of Neosentience. I'm going to talk about a new combinatoric n-dimensional bioalgorithm that I'm hoping to work with many people to develop, the 4 E's of cognition, the Insight Engine 2.0, and research areas for the Insight Engine 2.0. Monday will be much about the system. Tuesday will be researchers that we would imagine having be part of the database. So it's a very broad set of interesting papers. Neosentience, the Benevolence Engine, was a book that Otto Rossler, who's best known for his Rossler attractor, also has very interesting research into endophysics, which is a model physics world. But he was doing many interesting information-related works all through his career. And I'm actually working on a book about his history of his work, and Mark Bergen is doing annotations about the information relations in each of those areas. The book, interesting to know, Otto and I spent almost 10 years every week spending 1 hour discussing elements. And the Benevolence Engine, the Neosentience book, it has literally hundreds of micro chapters. And I often am very interested in the beginning moments of certain aspects of study. And you'll see in my paper that I'll be pointing to some of these. Of course, it's not responding to me now. Okay, human sentience is not typically used in the formal languages of either cognitive science or artificial intelligence, although it is our intention to explore it. The Neosentient model, although related to artificial intelligence, the long-term goal of this research using the Insight Engine 2.0 discussed later is the creation of an entity exhibiting a new form of machinic sentience. Neosentient, so instead of using the Turing test, we're interested of looking at a set of pragmatic benchmarks. So for example, if the system can do all of these things, then we would, for all intents and purposes, call it a neosentient entity. So the neosentient entity can learn, it can intelligently navigate, it can interact via natural language, it can generate simulations of behavior, it can think about potential behaviors, quote unquote, think, before acting in physical space. It can function in a creative manner. It can come to have a deep situated knowledge of context through multimodal sensing. It can display mirror competence, and it can function in a benevolent manner. So in terms of speculations, the idea would be that it would be brought up or brought to life in a social and cultural sphere of reciprocal interactions contributing to language and knowledge acquisition. This is achieved through embodied robotic relations to the environment, self, and others. The development of synthetic emotions would also be explored in the Neosentience. The way I look at it now, most AI they do not have a kind of a self-understanding or this idea of a kind of meta level about knowing about what a context actually means. So Otto Rossler's approach was something he called the brain equation, and that's written at length in his papers and also in the Neosentience book. The creation of such a machine via the embodiment of a series of specific algorithms on a parallel computing platform, or a new form of algorithm working in conjunction with a specific situated multimodal machinic sensing environment and situated robot. I've provisionally named this computational approach a combinatoric n-dimensional bioalgorithm. This may also be implemented via a new hardware paradigm. How do we best abstract human abilities related to thought and embodied learning and re-embody them in an anthropocentric machinic system? This suggests what Ross Asprey talked about. Cybernetics is the study of all possible abstract machines. And I've been very much interested in recouping a whole area of cybernetics and second-order cybernetics, especially related to the biological computer lab. I'll return back to that. So I like to point at the inception moments, and Reshevsky, very early on in 1933, foreshadowed many of the ideas that are discussed in the McCulloch and Pitts paper related to neural nets. Reshevsky's paper was entitled Outline of a Physico-Mathematical Theory of Excitation and Inhibition. And interestingly, Reshevsky was Pitt's teacher. So Reshevsky states, the aim of this present paper is to present a phenomenological theory, which however is susceptible of simple physical interpretation. It's not an attempt to merely add another possible expression to the great number of already existing ones, but to introduce what seems to us to be essentially a new point of view. This new point of view appears to give a rather simple explanation of many important phenomena of excitation and inhibition. Now, the later paper, 1943, 10 years later, is properly titled A Logical Calculus of the Ideas Immanent in Nervous Activity. And it's very interesting to go back and look at this paper, I think. After stating a careful and well-argued selection of simplifications of the behavior of real neurons, they develop a logical apparatus to define the concept of the solution of a net and of the realizability of a logical predicate by a net. Now, for me, this is one of the most interesting ideas that relates to neosentience. Von Neumann said, it is a fundamental requirement of the scientific viewpoint, the so-called principle of the psychophysical parallelism, that it must be possible so to describe the extra-physical process of the subjective perception as if it were in reality in the physical world. For example, to assign to it parts equivalent physical processes in the objective environment in ordinary space. I find that to be a fascinating thought in 1948. Now, Hava Siegelman is a very interesting researcher and who wrote this book, Neural Networks and Analog Computation Beyond the Turing Limit. So she states, the theoretical foundations of neural networks and analog computation conceptualize neural networks as a particular type of computer consisting of multiple assemblies of basic processors interconnected in an intricate structure. On a mathematical level, the treatment of neural computations enriches the theory of computation, but also explicates the computational complexity associated with biological networks, adaptive engineering tools, and related models from the fields of control theory and nonlinear dynamics. Now, So today, some of the most powerful artificial intelligence systems employ a type of machine learning called deep learning, as discussed earlier. Their algorithms learn by processing massive amounts of data through hidden layers of interconnected nodes, referred to as deep neural networks. As the name suggests, deep neural networks were inspired by the real neural networks in the brain, with the nodes modeled after real neurons, or at least after what neuroscientists knew about neurons back in 1950. When an influential neuron model called the perceptron was articulated and often attributed to Marvin Minsky, it was Frank Rosenblatt who did initial research. This book, 1957, The Perceptron, a Perceiving and Recognizing Automaton. And then this later book, Perceptrons, An Introduction to Computational Geometry, and that's by Minsky and Papper. Since then, our understanding of the computational complexity of single neurons has dramatically expanded. So biological neurons are known to be more complex than artificial ones, but how much? So to find out, David, and I can't pronounce this name, Ben Yud, Eden Segev, and Michael London, all at the Hebrew University of Jerusalem, trained an artificial deep neural network to mimic the computations of a simulated biological neuron. They showed that a deep neural network requires between 5 and 8 layers of interconnected neurons to present the complexity of one single biological neuron. So already we're talking about a very, very complex network. Thus, we just begin to touch on the complexity of such a future neosentient system. Again, going back to von Neumann, this axiomatic procedure. Axiomatizing the behavior of the elements means this. We assume that the elements have certain well-defined outside functional characteristics. That is, they're to be treated as black boxes. They are viewed as automatisms, the inner structure of which need not be disclosed, but which are assumed to react to certain unambiguously defined stimuli by certain unambiguously defined responses. So we are electrochemical computers of a highly complex variety. Thus, we can study entailment structures and make analogous functional substitutions in machinic systems. I think this relates much to the earlier paper. Sentience is an emergent phenomena that has not yet been fully entailed. As black boxes are replaced with the knowledge of articulated functionality, then emergence is replaced with entailment structures. The future of computing is perhaps of a mixed analog and digital nature. It's interesting to note that von Neumann decided to work with discrete because he didn't like the noise of the analog historically, or the emulation of the analog via a new form of high resolution digital formulation of the analog. And this is, Otto Rossler talks about this, that now you can make digital systems with a kind of level of complexities that mimic or emulate analog behavior. But that needs to be discussed, I think. I'm thinking that the future, we will explore the interrelation of multiple computational forms. And I wrote a paper, The Engine of Engines, toward a network ecology, I believe it was called, that some people might be interested in looking up. Okay. The body is an ultra-complex biomachine. This is what I would suggest, with a complexity greater than all human-made systems. Robert Rosen early on saw the limitations of the machine metaphor in relation to biological research, and he was quite skeptical. In a book published in 2000, Essays on Life Itself, Rosen points to a particular form of limit. And this is Rosen. I've attempted to introduce and to motivate a concept of complexity. A system is called complex if it has a non-simulable model. The science of such complex systems is very different from the science we have become used to over the past 3 centuries. Above all, complex systems cannot be completely characterized in terms of any reductionistic scheme based on simple systems. Since the science is different, so too are the technologies based on it, as well as any craft pertaining to the systems which that science deals. But later he sort of had a different sense. Perhaps we can devise an ultra-complex, this is me, simulable model, given the potentials of new computational systems. Or we can work toward building a system to explore complex mathematics and logic that enable new forms of modeling ultra-complex systems, or can we? Perhaps this is one of the highest goals of our project. Rosen in the 1999 text suggests, it's too early to tell how such ideas will develop in the future. My purpose here has been to introduce some of the flavors of the concept of complexity, how it pertains to basic biological issues, and how it may force a complete reevaluation, not only of our science, but of our concepts of art and of craft as well. And we can see all of the AI art, there'll be discussion of that on Tuesday. Indeed, it may turn out, as it has before, that the pursuit of craft may provide the best kind of probe to guide our science itself. Now, in terms of this idea, a new combinatoric n-dimensional bioalgorithm, what I'm quite interested in many different scientists putting papers into the Insight engine. Anyway, so cognitive behavior is approached through a series of information-oriented processes. Central is to define all of the entailment structures that inform the emergent arising of sentience in the human. And this is a very new, incomplete territory. And to seek to abstract those into an autonomous robotic system. And so I see this as a long-term goal. I mean, science now has a sort of one-year turnaround. I've already been working on this for about 20 years, so I think it's interesting. The system will bring together a series of technologies from the research of diverse scientists, artists, designers, and cyberneticists, and the study of complex systems to help map this time-based set of relationalities that bridge mind, brain, body, multimodal sensing systems, and environment. No single discipline of science, the humanities, and/or the arts can tackle such a difficult information-related problem set. A special transdisciplinary team of teams would need to arise out of the use of the Insight Engine 2.0. This overarching research team or set of teams would potentially consist of groups of specialists from a series of fields that would also learn enough about other member fields to be able to talk across disciplines. Researcher conversation would be central to the ongoing development of this new form of research into this variable bioalgorithmic network, contributing to Neosentience. Perhaps an earlier version of this kind of thinking was witnessed in the Biological Computer Lab, headed by Heinz von Forster, 1958 to 1976. Historical items related to the topic areas would be included in the database. For example, his study of bionics is absolutely fascinating. And very few people, when I ask all of my computer scientist students, have you ever heard of the Biological Computer Lab? And most of them haven't. So this is a quite nice book, An Unfinished Revolution, the Biological Computer Lab, which talks about its history. It was very much of the embodied embedded school that we're talking about in this conference, which was very different than we can do it all in the box kind of approach that Marvin Minsky and others were taking up at MIT at the time. The initial goal is to make the Insight Engine function in such a way. So the Insight Engine is this transdisciplinary research tool, search engine, to function in such a way as to point after Wittgenstein, philosophical investigations. Basically, he said, we can't get at things through language, we can only point. We can't get at language through language. To potential new research data across disciplinary boundaries by using advanced information processing, computational linguistics, a natural language API, we're very interested in using diffbot, and additional forms of AI acting as micro-peers, AI collaborators, to enable intelligent bridging of research questions and the development of new information paradigms through biassociation. Again, here's an early book by Arthur Kessler, his notion of biassociation. Actually, I'll return back to that in a moment. The Insight Engine information systems support researchers, empowering them to access relevant transdisciplinary information from the database to contribute to the higher order goal over time of articulating a functional neosentient model. Such a model is informed from many intellectual perspectives and transdisciplinary conversations facilitated by the system, a listserv, and future information-oriented conferences. The Insight Engine embodies a series of intelligent processing structures, visualization systems, the mapping of relationalities related to the corpus of papers, books, media objects, keywords, abstracts, diagrams, etc. Initially textually structured with pattern recognition, visual and sonic systems, soon to be integrated, that will help build and navigate the database and help outline the articulation of this very new combinatoric bioalgorithm informed by the deep study of human biofunctionality. Bioinformatic processing structures are to be abstracted and then re-articulated in a biomimetic manner or through bioabstraction in the Neosentient model. This dynamic, combinatoric, self-organizing system seeks to be resilient and interactive with the environment, building new knowledge up somewhat like humans do through pattern flows of multimodal sense perturbations, as well as incorporating a layering of other potential learning systems and access to distributed computational learning systems, much like us. How often is it that our own sensibility is augmented by our research in Google and searches and so on? So meta levels of self-observation and the development of language to articulate such contextual learning is central for the embodiment of the system. Okay, here's Arthur Koestler. So, by association, his idea, and this is from 1969, but I find it very unique. I've coined the term biassociation in order to make a distinction between the routine skills of thinking on a single plane, as it were, and the creative act, which I shall try to show always operates on more than one plane. The former may be called single-minded, the latter double-minded, a double-minded transitory state of unstable equilibrium. Now, he goes on to say the biassociative act connects previously unconnected matrices of experience. It makes us understand what it is to be awake, to be living on several planes at once. And this is what we're trying to make the Insight Engine do, that by interacting with the Insight Engine, you can click on, for example, one paper and another paper, and the system will go and look for all of the related papers and giving them a different ranking using this diffbot natural language system API. Okay. Now I've coined polyassociations, polyassociation processes brought about through AI in the Insight Engine. Polyassociation is drawing from multiple computational sources to define a research arena. So let's say I click on 5 totally different papers from fairly different areas. And one of the things about publishing is that there are certain groups of people where you might find something that's published, a very specific kind of publishing domain, which is very different and may never come across other published domains or that knowledge. So this is a way to build bridges between multiple areas of study, which I'm very excited about. Now, here's the deep problem. The problem is no one knows exactly what contributes to to our own sentient production and what can be left out. Yet this is no reason not to research in this direction, especially as a long-term goal. And as someone mentioned earlier, you know, there were these long-term places like different labs or even biological computer lab that had much longer term goals. The 4 E's of cognition: embodied, embedded, enactive, and extended approaches to cognition. The study of the operation of human multimodal sensing systems could be used to help define a computational pattern language that future robotic systems could make operative. This represents a set of processes that contribute to the development of a model for a neosentient, arrived at through biomimetics and bioabstraction. The goal is to unfold the embodied, embedded, enactive, and extended approaches to understanding cognition in the human, and then seek to articulate the processes and entailment structures that enable this set of dynamic interrelations to function. We seek to articulate a transdisciplinary, holistic approach, which will enable the examination of dynamic, time-based mind, brain, body, sensing, environment, relationalities. The Insight Engine 2.0 will seek to contain as many relevant papers and research embodiments, diagrams, documents, images, videos, etc., that are textually annotated, and or pointers to papers via the exploration of relevant abstracts, keywords, and the author's names and dates of publication. In fact, we very much want this to be a legal system. We've been testing a system that was closed where whole papers could come up. So we have a current set of overarching research categories in the system, and each research area will have a micropeer. These include the following, although new research areas will be added. So the initial categories: Neosentience, n-dimensional combinatoric bioalgorithm development, bodily entailment structures, mindful awareness, self-observation, second-order cybernetics, neuroscience, neuroscience and the arts, AI and the arts, computational creativity, biomimetics, the connectome, AI, AI and ethics, and this is a particular area of interest, EI, the biological computer lab, cybernetics and second-order cybernetics, bionics, science fiction, the history of AI, bridge building between disciplines, transdisciplinarity, a multi-perspective approach to knowledge production, information dash new approaches, approaches to learning. For example, Gordon Pask's conversation theory is quite interesting. Robotics and situated knowledge, computational intuition, android linguistics, a PhD student who's just completed computational media arts and cultures program, who's now going for a postdoc in Tokyo. He'll be presenting on Tuesday. Related new forms of mathematics, synthetic emotions, embodied computation. Now the research team, I didn't mention them up front, but they're all students except for one researcher from Duke. It consists of myself, John Herr, who works for the Office of Information Technology, who's helping to facilitate many of the things we're doing. Dev Seth, computer science student, Duke University. Ashley Kwan, computer science student, Duke University. Karan Karyan, a PhD student at CMAC, Computational Media Arts and Cultures at Duke. Kelsey Broad, a PhD student also at CMAC. And Mingyong Chen, who just graduated as an MFA at Duke, and is now a PhD student at UC San Diego. So you need to bear with us, and in the sense that we're currently still in the development mode, so researchers will be providing papers on work in progress. As you can imagine, COVID kind of put a spanner in the works for the research, so it took us a while to build it back up again. And now we've defined it as we're using the game engine, a game engine as the environment to do this in. So there'll be 3D worlds, but they won't be immersive unless you want to make them immersive. Okay, so let's see. So the goal is to search for active participants, and this is you in the audience, that would like to contribute links, abstracts, keywords, dates of publication, active link to distributor, or entire papers or books if you have legal copyright on those, as well as textually annotated images, video, and 3D models. So all in the future for people who might want to take part in this. Another class of participant will just be perusing the data. So there'll be researchers that are given a kind of role of uploading their research. And then there'll also be people that are just looking at relationalities and navigating things. We're very much interested in ethics and the paradox of bias in terms of AI authorship and use. Karim is a African-American who's much of his research is on bias, and this paradox has to do with, of course, an AI has to have a certain kind of bias. So how can we keep chipping away at it and be aware of that bias and try to focus on it in the most positive manner that we can. A lot of companies, you know, are kind of rushing through and have deep biases in their systems. Visualization modalities. A series of differing visualization modes will be explored from within the Unity game engine 3D environment, each exploring different interface metaphors as exploring relational information gleaned by the natural language API and micropeers and participants' interaction with the system. So these include these visualization modalities, trees and forests of information. If you do a search, it will literally grow this kind of tree in a landscape with all a series of papers. At the same time, any place that you click, you can see that at the bottom of the screen as a more traditional textual display. But because it creates this forest of information, you immediately can look through and see different kinds of categorizations, who the main researchers are based on height and a whole set of metaphors. We have molecule-like visualizations of information, a point cloud computational system of relational research papers, their author, keyword, abstracts, and online links. This was very interesting that the system would look at a huge corpus of papers and develop a point cloud set of relationalities. And by seeing the overlaps, you would automatically know there was a relation that you could then and see what it panned out to be. A keyword sentence generator suggesting new forms of research. This comes out of a playful, what I call recombinant informatics. My earlier artworks included a world generating system, a virtual world generator that enabled the building of virtual worlds in real time. And I wrote my PhD on this. So this was very early, 1997, for this kind of generative system. But also write about it as a way, a kind of discourse mechanism, because as you can call up and position things in the world as you interact with it. And of course, all of these things will be covered in papers tomorrow. Let's see. In each case, the researcher, while navigating in the 3D world and its different navigational modalities of search and discovery or entering more traditional textual search queries, will be able to select different bodies of information to navigate or save to their individual research repository or active group domain. So again, I'll end here. Please be in touch with me if you want to be included in future information emails about Neosentience and/or the Insight Engine or related future conferences. And so bill.seaman@duke.edu. I have a number of historical papers, some much more pertaining to the arts, and many are about the future of computer science, electrochemical computers, and so on at billseaman.com. And you can see my research bio at scholars.duke. And okay, I'll stop the share here. And if there are some questions or if we need to catch up and to stay on schedule, we could do that. Okay.
I have one thing. There was some problem with your presentation, so we could not see slides of your presentation, but somebody sent email that it will be available, like slides will be available on the website.
Yes, I can send the whole presentation. So you were just seeing a black screen the whole time?
Yeah.
Oh, why didn't you stop and tell me? That's weird.
Like, because someone wrote that I understood that you are aware of the problem. It was like chat message. Okay, slides will be available. So I'm sorry for this, but
I'm sorry. That's too bad. But yes, I can send the PowerPoint and yeah.
Thank you very much.